Life is short, way too short to do mundane tasks. Luckily, Apache Airflow can orchestrate your task for you so you can move on to more exciting things in your day. But first, you need to tell Airflow when those tasks need to run. Today, we'll look at the various ways of scheduling your Airflow DAGs. Let's dive in. First things first, when you define a DAG, you need to supply at least 3 pieces of information. Here we have some boilerplate code to set up a DAG. We're just importing our datetime object from the datetime module and then the DAG object from Airflow. And in our DAG context manager, we're giving those 3 pieces of information. We need to supply a DAG ID, so we know what DAG we're looking at. We need to give a start date, usually a datetime object, and then the schedule, which tells the Airflow infrastructure how often you want this DAG to run. In this example here, our amazing DAG has a start date of January 1, 2025 with a time of midnight, and we're scheduling it to occur daily. If you're familiar with DAGs, you know that within this context manager, you would define the tasks and the order in which the task should run. But for today, we're just focusing on what the schedule parameter could be and how we can orchestrate or schedule our DAGs. Pop quiz. When do you think this DAG will first run? If you're like me, you might think that the first run of the DAG will be, well, January 1st, 2025 at midnight. And like me, you'd be wrong. The first run is in fact not on January 1, but on January 2nd at midnight. This is because Airflow has a concept called data intervals. The idea is that every time a DAG runs, it should process data associated with a certain window of time. In this case, since we have a start date of January 1 and are setting our schedule as daily, it will wait for the first 24 hours to capture the first data interval, and then once that first window closes on January 2nd at midnight, it will execute for the first time to capture this interval of data. Maybe another example would be if you have a DAG that is scheduled to start today at 3 p.m. and it's going to occur every 10 minutes, the first DAG run won't be at 3 p.m. It will be at 3:10 p.m. after the first time interval of 10 minutes has passed. So keep this in mind as you schedule DAGs. It can be something that can cause a headache if you're not looking out for it. All right, with that out of the way, let's move on to the 4 components or 4 objects that we can pass to our schedule parameter. We'll look at Cron, Timedelta, Dataset, and Timetable. First up is Cron, an oldie but a goodie. It's been used for many decades to schedule tasks in different Unix-based systems. And if you haven't seen it, it can be a little daunting at times, but it's not too bad. Cron expression is basically a string of 5 components, and the components include the minute, hour, day of month, the month of the year, and then the day of the week. The best way to learn about Cron is by going to this website, crontab.guru, where you can interactively experiment with different Cron expressions. Here on this website, we can see that we have a expression of 5 for the minute, 4 for the hour, which would indicate 4:05. And then for the day of month, and day of week, we have star, 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 which is basically a wildcard that indicates any day, any month. Collectively, this then says that our DAG needs to run at 4:05 on any day, any month. And you can experiment with different values. If we click this random button, this particular expression would say that we want our DAG to run at 00:05 any day of the month, but only on the 8th month, or August. It's pretty flexible, and it can be used to schedule your DAGs as a starter. Some schedules are used so frequently that in addition to standard Cron expressions, Airflow allows you to use something called preset Cron expressions. And those are more human-readable ways of representing Cron. You could, for example, in place of passing in these Cron expressions on the right, you could pass in any of these preset values, which are more human-readable strings, like daily, weekly, monthly, and so on. And Airflow will take these expressions and convert them into their Cron equivalent. What if you had more unique situations that you wanted to represent as a Cron expression? Suppose, for example, you need to run a DAG on the second Friday of every month. Well, Airflow allows some extended variants of cron beyond the standard that's been defined for many decades. If you wanted, for example, the second Friday of each month, you could start by saying 3014 star star 5, which is 2:30 in the afternoon on the 5th day of the week, which would be Friday. But this, of course, would only work on every single Friday. If we just wanted the second Friday of the month, in the 5th position, you could pass in a #2 to indicate that we want the 5th day of the week, but only the second instance in a given month, or second Friday of the month. Now, if we tried to type this into cron tab, you'll see that it doesn't quite work. We have 3014 star star, and then of course this represents every Friday. And if we try to put in the extended cron expression with #2, this does not compute because it's outside of the standard cron that many systems are expected to use. But we can verify that this works in Airflow. Let's go to our local Airflow instance. Here we have some DAGs to demonstrate different scheduling techniques. Right now we'll focus on just the cron expressions. And here in our day of week hash DAG, we can see that we're using a schedule of 1300 second Friday of the month. Just to verify it, if we look at the code and go down to that expression, here we see that particular schedule, and we can verify that this is working by, in the UI, going over to the calendar tab. Here in the calendar tab, you can see that we have at least one DAG run that was a manual DAG run I performed, and then a dot or a little circle for each of the DAG runs that are scheduled in the future. So here for the February, we can see that our next scheduled DAG run is February 14th. Happy Valentine's Day. And then as you go through the year, you'll see more and more DAG runs, all of which are happening exactly on the second Friday of each month. Pretty cool. Let's say you have another example where you need to run a DAG every 10 minutes. There's a couple ways of doing this. In cron, you could write out every 10 minutes as part of the expression itself. For example, the 0th minute, the 10th minute, 20th, 30th, 40th, 50th, so on and so forth. Too many stars. And this would say that I want my DAG to run at all of these times on any day, any month. But you can probably tell this is a bit verbose. One way to go around that is by using a step value where we use a /10 to effectively take whatever interval or component we're looking at and break it into equal components of 10 units. So for example, here we could get the same exact thing by just taking our minute expression and in place of that putting */10, which would be every 10th minute, and the next one would happen at 2 o'clock in my local time. That's how you can use cron expressions to schedule your DAGs, but there's more. You can also use, in place of these cron expressions, the Timedelta object from Python's datetime module. For example, if we wanted to get every 10 minutes again, then we could, in place of the schedule parameter, pass in the Timedelta object with 10 minutes. This would do the same thing as the step value function we used before. And so you might be wondering, why use Timedelta at all? Well, in this scenario, yes, we can use cron to get the expression that we want of every 10 minutes, just like Timedelta. But there are certain situations where cron just doesn't work. Suppose, for instance, that you wanted to execute a DAG every 4 days. Think about how you might do that. Say that you have your DAG starting on the 1st of the month and you want it to execute every 4 days. You could try to force this in cron. Let's see what that might look like. You could say I want it on the 1st day, and then 4 days later on the 5th day, 9th day, so on and so forth, and then put in stars for everything else. But you might recognize that this creates an issue at the end of the month when you transition to a new month. Let's check it out. Suppose that we're looking at just this month, and the month before and the month after. If we wanted to get every 4 days starting on the 1st of the month, then of course we could in cron schedule the 1st, the 5th, the 9th, so on and so forth. up until we get to the 29th. But then something would happen. If we had hard-coded specific days of the month to simulate every 4 days, then from the 29th, the next run would happen on the 1st, since we hard-coded a 1. But that would break the rule of every 4 days, because you would just have 3 days passing from the 29th to the 1st. And let's just not forget that some months have 28 days, some have 29, some 30, some 31. So hard-coding these kinds of dates in Cron just doesn't work when you want to get something like a relative schedule or a frequency-based schedule. In such scenarios, Timedelta comes in to help. In place of the schedule, again, we can put in a Timedelta object where we pass in every 4 days. And if we go back to our Airflow UI, we can see that that is doing what we would hope it to do. Let's go back to our DAGs and look at our Timedelta DAGs now. And we'll focus on the DAG that is scheduled to run every 4 days. Back in the calendar, you can see, again, dots for every 4 days that something would run. And let's just look at a month like March here. Here we can see that in March, we have a DAG scheduled to run on March 25th, and then again 4 days later on March 29th. And then, as expected, it'll execute 4 days later on April 2nd, instead of the hard-coded one that we would have had if we tried to use Cron. Pretty cool. So now we have 2 scheduling methods, Cron and Timedelta. What else is there? Well, a relatively newer way of scheduling DAGs is the dataset. And this is useful when you have situations where you can't schedule a point in time or somewhere on your calendar for your DAG to run. This might happen because you're waiting on some file to complete or some other process to be done before you can schedule your DAG. These kinds of scenarios are called event-based scheduling instead of time-based scheduling. Now, Airflow has long had ways of handling dependencies between DAGs. There's the triggered DAG run operator and the external task sensor operator. But these methods are a little bit clunky, and at times they can be tough to debug. A newer way of scheduling DAG dependencies is called the Airflow dataset, capital D. And in short, in Airflow, a dataset is basically just a string that represents some kind of data that's being created or updated by some other DAG. Let me show you what I mean. If we want to use a dataset to schedule a DAG, what we first need to do is define that dataset, and then define the DAG that updates that dataset and another DAG downstream that uses that dataset. Here's our code again. We have our same import statements, but this time we're importing from airflow.datasets the class dataset. And in this line here, we are instantiating a dataset object, passing in one required argument called the URI. This is that string I was talking about. The URI is just a string that represents some data. In this case, it's a file path to a text file in my local machine, but it could just as well be a S3 object or some table in a Postgres database. What the data is really doesn't matter because Airflow doesn't check to see if that data was legitimately created or updated. This is just a string to let Airflow keep track of what DAG creates that data so it can then know what downstream DAG to trigger. So below we have 2 DAGs. We have one DAG that produces this data set and then another DAG that consumes that data set. In this producer data set, we pass into this task a outlets parameter. So in the outlets parameter, we reference the dataset that has been defined earlier. And what this collectively does is tell Airflow that in this DAG, in this particular task, I'm doing something to create or update my dataset. And then Airflow will then know that any downstream DAGs that use this dataset need to immediately run. That's done down here in this DAG. In the consumer dataset, we pass into the schedule parameter a reference to the exact same dataset. And this is how Airflow knows that once the dataset defined above has been updated, that this DAG needs to be executed. Let's hop over to the UI again to look at an example. We'll look at our Dataset DAGs by filtering for that tag. We have our two DAGs here, one that creates the dataset, in this case a local text file for demo purposes, and then one that consumes it. You can see that the producer dataset has a cron schedule. It's going to execute at 3:45 p.m. on the 4th day of the week. And then the consumer DAG, its schedule is defined as the dataset. And we can demo this. Let me make this a bit bigger. What we'll do is manually trigger the producer DAG, and once this DAG is complete, Airflow should trigger the consumer DAG. Let me go over and press play, trigger DAG. What will happen behind the scenes is the producer DAG will create a text file on the local worker. That is done, and now you can see that the consumer DAG has been executed. And that is complete as well. Let's look at it. We can see that the most recent DAG run that we just executed happened today, March 27th at 20:06 UTC time. And in the graph, we can see that after the dataset was created, it was recognized as an Airflow dataset that was updated. That then triggered our second DAG that most recently ran at the same time, about the same time of January 27 at 20:06. You can see the run type is different. It's a dataset triggered instead of manual or scheduled, and we can furthermore see such dependencies between DAGs by going to the Datasets tab and clicking on Dependency Graph. Here we can see all the DAGs in this Airflow instance that rely on a dataset to coordinate between DAGs. Datasets are cool. They're a great way to organize DAG dependencies. That's the third way to schedule a DAG. What's the last one? The last technique is to use a timetable. Timetable sounds new, but you've kind of been using it already. When you schedule a DAG with a cron expression or a Timedelta object, Airflow will take that input and convert that to an internal timetable that is used to schedule or organize our DAGs. There are situations though where you can't use a cron expression where you can point to somewhere in the calendar for the DAG to run, and maybe you can't use a relative frequency like every 4 days. Sometimes you just need a DAG to run on very specific days. For example, if you're in the financial markets, you might have a process that needs to run on the days that the stock market is closed. In such situations, you can create a custom timetable and pass that into the schedule parameter of your DAG. Here's how we can do it. In addition to the normal import statements, we have an import of the events timetable class from the Airflow timetables events module. And it's fairly straightforward. What we do is define the specific days or date times that we want our DAG to run. In this case, I'm just passing in some dates in 2025 where the stock market will be closed, in addition to a very special birthday, and instantiating that and storing it in a variable called myEvents. Then when you define your DAG, you pass that object to the schedule parameter, and Airflow will take this DAG and execute it only on those days that you mentioned. Back at the Airflow UI, if we look for this DAG, the timetable based DAG, there's already been a manual run, but in our calendar, we can again see the various days that this DAG is scheduled to run. Starting out with, I think, President's Day, and then Memorial Day, Juneteenth, 4th of July, so on and so forth. This technique works because we have a finite amount of dates. We don't have a very long list that goes on forever. You might have a situation where you do need to get even more complicated. For example, maybe you have a DAG that runs every other week, and on one run, it starts at 4 a.m., and in the next run, it starts at 4 p.m., and it goes back and forth. Perhaps you have a DAG where you need to execute the process at sunset, and that might be something special that you need for something related to astronomy or weather. In these kinds of situations where it's really hard to define in code what your schedule should be, Airflow has more advanced timetables, and the best way to learn about that is just going to the documentation that Airflow has. Essentially, what you need to do if you have such complicated timetables is to create a Airflow plugin by inheriting from the base timetable. And this document walks through the more advanced processes of scheduling DAGs that way. However, most of the time, the methods we discussed earlier should be just fine. We can use our cron expressions, our Timedelta objects, dataset for event-driven planning, and in this case, events timetable if you just have some specific dates that you need to call out. If you're curious about these DAGs and you want to play around with them yourself, you can go over to the KP Data Dev repo, and in the folder for Airflow scheduling, you'll see a few instructions to get Airflow up and running so you can work with these DAGs yourself. It's essentially just Docker running on a local worker, and once you have it operational, you can look at all of the DAGs and the various ways that we have looked at scheduling our DAGs. Hope you enjoyed, hope you learned something. If you liked it, please like and subscribe, and if you have any questions, drop them in the comments below. Until next time, happy coding.